In the previous video, we showed solving exponential and logarithmic equations. We looked at how we did that, specifically just looking at logarithmic equations. So we looked at combining different parts of it, getting them as one saying, and then how we solved it for an answer. So for example, the one where we had log to base 2 of 7 equals log to base 2 of x plus 3. How we solved that, how we combined it all together, and how we were able to solve that. Well, in this, we're going to keep going with that sort of thing, but we're going to look at just the exponential part of things. So what happens if we have an equation where it's an exponential equal to something? So e to the x equals 7. And how we'd solve that for getting x. These are the kind of things we have to be able to do, is solve something like that. But it's actually quite easy. What we have to do is make sure we get the terms together and we take the log of the sides. Now, taking the logs to get rid of the e and get the numbers on their own is one way of doing it, but it doesn't matter what base we take our log as being. Let's have a look at a couple of examples just to show it. So let's imagine I want to solve e to the x equals 7. So let's imagine I do that. Now, there's a couple of ways we can do that, but the thing that instantly we think about is if we did log to the base e of e to the x, we know that that's the same as x times log to the base e of e, and then the log to the base e of e cancels to make 1, and we get x. So what we can do is take the log to the base e of both sides here. So let's imagine then we get log to the base e of e to the x equals log to the base e of 7. Once we've done that, we then rearrange things. So we get x times log to the base e of e to the x equals log to the base e of 7. This goes to 1, and we know then that x equals log to the base e of 7. Once we do that, we stick it all on a calculator, work it through. We get x equals 1.946 to 3 decimal places. So doing that and getting rid of the e here is a perfect way of doing it, because then we can get it down to x. But it doesn't matter what way we do or what we use as a log. So for example, imagine I take the e to the x equals 7, and I then take log to the base 10 of e to the x equals log to the base 10 of 7. Well, the rules can still be the same. My top here can still go down in the number in front, and I get x times log to the base 10 of e equals log to the base 10 of 7. The only issue here now on this one compared to that one is log to the base 10 of e doesn't cancel and give me 1 because they're different. So I've got to keep it like that. Now, in order to be left with just x on this side, I take this and divide it across. So I'd end up getting log to the base 10 of 7 divided by log to the base 10 of e. Once you've done that, you fire it in the calculator and work it through, and lo and behold, you actually get 1.946 to 3 decimal places. It doesn't matter which we take. Log to the base e, log to the base 10, log to the base 5, log to the base whatever. Using our normal relationships with the x and using the properties that we've covered in previous videos, we're able to do it and then get them all together in one go. And once we've done that, we can use our calculator to solve these out. Let's look at another example. So let's imagine we're looking at something that says 5 to the power of 3x plus 1 equals 40. Now we want to solve something like this, so the first thing we need to do is get the 3x plus 1 down, then get all the numbers onto one side, and then take it from there. So first thing we need to do is take the log on both sides. Now what I'm going to do is I'm going to take the log to the base e of 5 times 3x plus 1 equals log to the base e of 40. Now, again, it doesn't matter which of these we take. We take e as a normal standard function, but you could have had log to the base 10, whatever. It would eventually still work out being the same. Use our normal property here, so we could bring that down in front. And we get 3x plus 1 times log to the base e of 5 equals log to the base e of 40. Bring this across, and we get 3x plus 1 equals log to the base e of 40 divided by log to the base e of 5. Once we've got that, we can calculate this part here. So log to the base e of 40 divided by log to the base e of 5. If we were to calculate and do it to 4 decimal places, we get 2.2920. So 3x plus 1 equals that. We can then solve it as simple. So if we take the 3x, subtract 1 from both sides, we'd get 1.2920. So if 3x equals that, divide both of them by 3. So we divide here by 3, divide there by 3. We then know that x equals 0.431 to 3 decimal places. Working them and solving them just like an equation is actually fairly straightforward. We can use the different value for e within our log. It doesn't matter as long as we're consistent. Now we tend to usually stick with log to the base e or log to the base 10. Stick with these if you can when you're doing the exercises to there. Just remember the different rules that we do and how we work them through and how we solve them from there.